Hello everyone. In this video, we'll shortly discuss some points related to static variables which we have implemented previously. So we have implemented static variables in such a way previously that we were able to access it from the instantiated object instead of the fish class itself. And that was done intentionally at that point because it doesn't make much of difference while we use variables or how we use those variables, but it can be quite complicated to understand the way we implement it to push those variables from the objects to the class to the class itself. So let me clear it up on the topic what I'm saying. Right now, if we try to access this variable, get total fishes, then we are accessing it from the Nemo object. And Nemo is the instance of fish. But ideally what happen, we should be able to access it from fish, but not Nemo object. So it's actually quite easy to shift it there, but when we'll shift it, we'll face one other problem that is easy to solve but tricky to understand. So now let's look into it. What we can do is instead of adding this function to prototype, we can add this function to the fish object itself. And this should solve our problem. Now, this gives error. And if we try to access it from fish, this works fine. But next thing that breaks is when we try to access it from the shark object dot get. So this gives error. But since shark is in fish only, we should be able to get the count of total fishes from shark as well. And this is more of a design choice that if we want to have this function attached to fishes only, or if we want to have this function attached to sharks as well. So this design choice we have right now in our hands. So if we choose to attach this function to fish only, then it's not difficult, then it's done. But if we want to attach this function to all the child classes as well, then we would have to make some clever changes. Let's make those changes in code first, and then we'll discuss that what we did and how did it work and why it didn't messed up the code entirely as well. Because it's not muchly, but sometimes people get quite confused over it. So what we'll do for every new constructor function, the reason why it's not there in Shark is if we open Shark object, it's not it's not related to fish object at all, and the function that we are trying to grab is there in the fish object. So if we need to access something from shark that resides in fish, what is the only possible way? Only possible way is that we set the prototype of shark as a prototype of fish, and would have to do similar thing for all of our objects. So let's do it for jellyfish as well. And let's do it for hammer as well. Hammer shark. Now the problem is actually fixed. So if you see, we can access it from fishes. We should also be able to access it from hammer sharks, and we should also be able to access it from sharks. We can also access it from jelly. So it was a quick fix, but the typical thing is to understand what we did and why we didn't break anything. So let's go back to our diagram that we had created, and it's quite a fuzzy diagram, but it will help us to understand its prototype and its prototype. So previously we had created only one prototype chain that was linking our prototype objects, which is this, which is this, and from here it was this, and this was base object, so it actually pointed to capital object. And this is what we have done in previous lectures. Now what we just did is we took the constructor function of the leaf node here and we pointed it to the parent's constructor function. We pointed the prototype of this constructor function as shark's constructor function, and we did the same between these two, and we did the same between jelly and fish as well. And since fish is at the root, then it will actually point to function. Let's go and check the same if it follows. If I open hammer shark and if I open fish, if you see fish is a function, and any function in JavaScript has a prototype of function there. But we changed this prototype for hammer shark function and we changed it to shark, as I depicted it here, that we changed the constructor function's prototype to shark. And then we changed this prototype to, now you check what's the prototype of shark function. Shark's function has the prototype of fish function, as we pointed it here. And then if we check the fish function that we have already checked here as well, it has a prototype of function, and similar will follow for jelly as well. We open jelly here. So you see, we have pointed it towards fish, and we just did it here right now, that which these prototypes for this chaining to be possible. And it is totally up to our hand how we link it or how we implement it. This can be difficult to understand. So that is the reason that I didn't bring forward this idea previously while we were discussing all those things, because it could have created a lot more confusion and might not be the best way to explain complete hierarchy at once. So, and the bigger question that most people have after looking at this particular thing is that if we change the prototype of hammer shark in shark, how is everything still working, and why is why is there is no error, or why something is not breaking? Because we changed the prototype that was setted by JavaScript itself, and probably this hammer shark should not work as as a function itself. It's working because hammer shark is a function, and whenever we add any function, it looks for the actual function call somewhere. So these are the actual properties: arguments, bind, call, caller. These are the actual properties that should be attached to hammer shark somewhere. Since they are attached here, that is the reason that we are not breaking any of the functionalities on how hammer shark should act and react. So see, main properties are apply, bind, and call that are here. Okay, the next question could be, can there be a case when it breaks something? Yes, there can be a particular case when it breaks something. If we try to define specific properties, so right now what we tried to define, we tried to define one particular property, that was get total fishes. But if we try to define call, bind, apply, and toString, these properties that are there from the actual prototype, if we try to redefine them here, then we might end up breaking something. So we need to be very careful while playing with this function hierarchy, because here we can very easily mess up things if we do not choose our variable names very judiciously. So take your time to understand, take your time to look at the code. If it seems difficult, but it's not that difficult actually. And let's just get to the next video.